Hello, hello. 12.3 inscribed angles. When you hear inscribed, think of inside. So angles that are inscribed of a circle. First, you have to know what an inscribed angle is and an intercepted arc. So I would draw out this picture right here and label it correctly. An inscribed angle means that the vertex lies on the circle. Right here. And an intercepted arc is the arc in between the two endpoints of the circle. So right here, this would be angle ACB, and then the arc is AB. Now, when we have an inscribed angle, like here, angle B, it's always going to be half the measure of the arc. And these are the three different pictures that could show up for an inscribed angle. You could have that one length is the diameter and the other length is not. But again, that vertex always has to lie on the circle, and the two other endpoints also lie on the circle. You could have the two lines with the center of the circle inside of the angle. Or you could have the two lines with the center of the circle on the outside of the angle. Either way, this distance is always going to be half of this distance. So it's always half the measure of the arc whenever you have an inscribed angle. So let's use that, shall we? When you're looking at this picture, you should always trace out, what do I have, what am I looking for? So one thing I'm going to trace out first is this arc right here. A is an arc I am looking for. Okay? So once I have the arc, now I'm going to trace out what's the angle that goes with that arc. So starting at the endpoints of the arc, then I want to go move, okay, here's the angle that I'm going to use to help me figure out what that angle is, or the arc is. Now if this is half the measure, that means the arc is double. So I can do 60 times 2. So A is going to be equal to 120 degrees. Because when I have the angle, I'm always going to multiply that by 2 to get the arc. Now if you look at angle B, again, trace out, this is what I'm looking for right here. So that means I have to know this arc right here. Two things. I already know that this arc, angle A, is 120. So if I look at this whole arc, this section is 30. So the whole arc is going to be 150. Now, when I'm going from the arc to the angle, it's always going to be half the measurement. So if I do 150 divided by 2, that's going to give me B. So B is going to be 150 divided by 2, or equal to 75 degrees. Again, arc is always going to be larger than the inscribed angle. What is the measure of angle A? So again, I'm going to look at this angle right here. Once I trace out the angle, the arc is going to help me. When I'm looking at this arc, it looks like it's half of the circle. Well, the whole circle is 360, so half of the circle is going to be 180. So this arc is 180. If I go from arc to angle, I have to divide by 2. So this would be 180 divided by 2. So angle A is going to be equal to 90 degrees. I want you to attempt this problem by yourself. So if you follow my colors for this problem, you will see that angle A would be 190 because my whole arc here is from B to D. If you look on my picture, that's the green. So 100 plus 90, and then I have to divide it by 2 because the inscribed angle is always half the arc. Angle B is in between points A and C. So that means I have to add up that total arc measurement. That's where I get the 154 from. And that B divided by 2 is 77. Angle C is going to be in between D and B. So I have to make sure to add 106 plus 64. And that's where I get the 170. Divide that by 2 is 85. And the last angle, angle D, is in between A and C. So if I add up 106 plus 100, I get 206. Divide that by 2, 103. So we have 3 different properties about inscribed angles, and I would draw a picture for each and write down what it's saying. So in this problem, if I have 2 inscribed angles at angle A and B, and they subtend the same arc, meaning their endpoints are at the same arc. Both angle A and B have the endpoints at these 2 points. That means angle A is going to be equal or congruent to angle B. The second one, if my angle, which we've already proven, subtends a semicircle, subtend means the arc in between the 2 endpoints. So the arc in between the 2 endpoints is a semicircle. That means that angle is going to be 90. Because a semicircle is 180, so 180 divided by 2 is always going to give you 90. And if I have a quadrilateral inscribed, meaning there's a quadrilateral with all 4 points touching the circle, like this, that means opposite angles are going to be supplementary. If you don't remember what that is, that equals 180 degrees. Supplementary, so opposite angles are supplementary. Make sure you wrote that down and you have that as a good reference to look back at. So I'm looking at the numbered angle. So if I look at this angle right here, and then I'm also going to put the arc that's in between my 2 points right here. Well, when I look at this arc, I see that it's a semicircle. That means that this angle has to be 90 degrees because it's in between a semicircle. So angle 1 is going to be equal to 90 degrees. Now if I look at angle 2 here, here's my point, and here are the lines that make up that point, right here and right here. I can see that the arc in between them is the same arc for this angle right here. So since these are in between the same exact arc, that means these 2 are going to be congruent. So angle 2 is also going to be equal to 38 degrees because they subtend the same arc, meaning their endpoints are at the same spot. For this problem, I want to figure out what each one of these angles are equal to, so this dotted line is here to help me. So if I drew in this angle right here, this arc in between is going to help me get this angle, because it'll be 60 divided by 2, so that's going to give me 30. And this arc right here is going to help me get the second part of that. 80 divided by 2 is 40, so angle 4 is going to be equal to, add these 2 together, 70. The other thing I know about inscribed quadrilateral, since all 4 vertices are on the edge of the circle, these 2 angles are going to be supplementary. So angle 2, I can do 180 minus 70 to get 110 degrees, because supplementary means adds up to 180. And then finally, I'm looking at my angles 1 and 3. Both angle 1 and angle 3 subtend a semicircle. So if they subtend a semicircle, that means they're both going to be equal to 90 degrees. Bing bada boom, there's my answer. And the very last property that we're going to be going over is if an angle is formed by a tangent line and a chord. A tangent line, again, only touches the circle at one spot, like this, and a chord goes through the circle, like this. This is the formula we would use right here. It's always going to be half the distance of the arc in between them. So in between this angle, I have angle BDC right here, because I start at B from the chord to the vertex, so it would be half that angle measurement. So you have to be very careful when you're looking at the picture of what the angle is. Like in this picture, I'm going the long way around because that's the arc in between the angle that I'm talking about. Always half the distance of the arc, just like an inscribed angle. In this diagram, SR is tangent. That means it only touches the circle at this point right here. It's telling me PMQ, arc PMQ, so I'm going to label that right here. This is equal to 212 degrees. So asking, what's the measure of PQR? This angle right here. Well, when I look at this picture, there's two ways that I could figure this out. I could figure out what this arc is, and that would help me figure out the angle. Or I could figure out what this angle is, and that would help me figure out my angle. Either way, you're going to get the same answer. I'm going to figure out what this arc is, because in a whole circle, if I started Q and go all the way around, that would be 360. Well, I only really want to know what arc PQ is equal to. So I'm going to take 360, because that's my whole circle, minus 212. I'm subtracting away the pink part. So then my arc is going to be equal to 148. That's what this arc is equal to. So now when I'm looking at my angle here, this is tangent. That means the arc that goes in between is going to be half the distance of this angle. So if I'm looking for angle PQR, it's going to be equal to half of 148, which would be 74 degrees. Make sure you took wonderful notes writing down each type of property and a problem that goes with each type of property. Otherwise, no points for you. Have a great day.